All right, so let's look at graphing some more polynomials. Here's a question. We're given a few conditions, and we need to graph a polynomial function that matches these. Okay, so let's try this. How hard could it possibly be? So all the points, graph them first. You don't have to be precise here. So at 2, we're at 10, so we have to go through this point. At -3, we're at 0, so there's an x-intercept at -3, and also at a4. So those are the first 3 points. And then it says the y-intercept is also 0, so we know we go through the origin, right? So we have 4
Mhm.
points. And then so we did this condition, we did this condition. Let's look at this one. F of x is greater than 0. What does that mean? That means it's positive. Our curve is above the y-axis when x is less than -3. So to the left of -3, our curve is above the y-axis, and also between 0 and 4, we're above the y-axis. So maybe like this. And then between when we're less, no, I messed this one up, didn't I? No, I didn't. We're good, we're good. So that's the positive quadrants. It's between here and here. Now for the next one, it's a negative quadrant. F of x is less than 0 means it's negative when the curve is between -3 and 0, so maybe right here. And when x is greater than 4, it's a negative. So there you go. That's gonna be our curve. What would be the equation for this curve? So a polynomial, right? If you think about quadratics, it's gonna be in this form. That's for a quadratic. Cubic, you just add another one. Quartic, you just add another one. Yeah? So how
Mhm.
many zeros do we have? How many
Three.
x? Yeah, so there's 3 x-intercepts. So is this a cubic, quartic? What kind of a function do we have here?
Cubic.
Is it a cubic though? Yes, it is, right? It is a cubic. And cubic can have 3 x-intercepts. So we know this is a cubic function. So let's set it up. A on the outside, and in the inside is just like the transformations. It's always x minus. That's the
Mhm.
default. So it's gonna be for -3, it becomes x plus 3. For 0, well, it just becomes an x, or x minus 0 if you really wanted to, and then x minus 4. Now, to answer the question, what's the equation? We also need to find the a value. To find the a value, you plug any point that's not an x-intercept. You're not allowed to plug these in. Because if you plug the x-intercept in, you'll be multiplying by a 0. And then you get something like this, where a is like 3/0 or something, which is something weird. So you cannot plug in the x-intercepts. It has to be a point that is not an x-intercept. So the only thing we can plug is 210. So when x is 2, the y is 10. Like that. So what is this? -20. So a is -1/2. So for the final answer, it's -1/2. That times that times that. Does a being negative make sense here from the curve? Is a negative or positive? If you look at the curve for a cubic function.
Negative.
Negative, so it does make sense, okay?
Mhm.
It does make sense. So that was not too difficult. So let's keep going. It says describe the end behaviors of this function. So whenever a question asks you for end behaviors, every single time, right? Every single time you're going to be doing this. As x goes to positive infinity, y goes to blank, and as x goes to negative infinity, y goes to blank. So as x goes to positive infinity, so x positive infinity we're looking at here. So the y value that we're looking at is down here. What's the y value down there?
Negative infinity.
Negative infinity. What about on the other side? When x is negative infinity, what's the y value?
Positive infinity.
Positive infinity. And there you go. Because it's an odd degree function, it's a cubic function, the n behaviors are going to be different. For even degree polynomials, the n behaviors are going to be the same. By that I mean for even every single time, doesn't matter as x goes to positive or negative infinity, y is either going to go positive infinity or y is going to go negative infinity for even functions. Whereas for odd functions, it's different. The n behaviors are different. Let's look at this one. It says, state the possible degree of each function. All right, so what's the degree of this function? Possible
3.
degree. 3. The sign of the leading coefficient. Is it positive or negative?
It's positive.
It's positive. And the number of turning points.
2.
2. Very simple question. We can actually ignore these. Mm, These are pretty simple, honestly. Let me see what we can do. All of these are very simple. Maybe we'll do one. Maybe we'll do this one. So the question is to graph this polynomial. What kind of a function do we have here? What's the degree?
4.
4. So how do we graph this? What do you need to graph a polynomial? Think about a quadratic. We need some things to graph a quadratic. What are they?
The x's.
Yeah, the x-intercept is probably the most important. So to graph this function, we have to be able to factor it, yeah?
Mm-hmm.
How do you factor a polynomial? Think about it in terms of the remainder factor theorem. To factor this, we need to come up with an x-intercept, okay?
Mm-hmm.
We need to come up with a 0. What are some possible values of zeros for this function? Zeros, they always come from the y-intercept. They will always be factors, in fact, of the y-intercept. So what are some factors of 9?
3, 9, and 1.
Yeah, so it's going to be plus minus 1, plus minus 3, and plus minus 9. So these are your possible x-intercepts. And the annoying thing is that you have to check for all of them, which is really annoying. So 1 and negative 1, I don't think is going to work. I don't want to have to eat my words. Yeah, I don't think 1 and negative 1 is going to work. So I'm going to jump to 3 straight up. So let me plug 3 as x. 4 times 3 to the 4 plus 4 times 3 cubed minus 35 times 9 minus 36 times 3 minus 9. Yeah, so I plugged F3 in there. I got exactly 0. So what's our factor? What's the expression? What's our divisor term? It's x minus 3, okay? X
Mm-hmm.
minus 3 is a factor. So that's step number 1. You're going to come up with possible factors for this function by using the y-intercept. And once you figure that out, the second step is going to be, well, if it's linear, this is linear, so it's going to be division. I'm going to use synthetic. You want to break down the function. So synthetic division, 3 comes here as is, and all the coefficients go in here in descending order. If any of the coefficients are missing, in this case, we have nice flow from 4 to 0, so none of them are missing. But if they were missing, you have to put them in as a 0. In synthetic division, the first number here always comes down as it is. This becomes a 4. And then the next number goes over here. The next number is going to be your divisor times the number down here. What goes here?
12.
12. And then in synthetic division, instead of subtracting, we add. What goes here? 16. 4 plus 12. What goes here?
48.
48. 13. 39. 3. 9. 0. If you do this right, every single time your remainder should be 0 because it's a factor. Remember factor theorem. If it's a factor, the remainder is going to be 0. Yeah?
Mm-hmm.
So here we know that the remainder is going to be 0. So always expect a 0 here at the end. So what's our quotient then? We had a quartic function. We divided it with a linear function. So what's our quotient? So your quotient comes from down here, right?
Mm-hmm.
So your quotient is going to be 4x cubed plus 16x squared plus 13x plus 3. So that's your quotient. How do we factor a cubic function? It's the exact same thing, yeah? Exact
Mm-hmm.
same approach as we just did. What's the first step? What did we do up here? We found possible values for the factor. So here, the possible values are going to be plus minus 1 and plus minus 3, okay?
Mm-hmm.
I think minus 1 might work here. So let me try my plus 1 is not going to work. There's no way that's going to give us a 0. Let's try minus 1. Nope. Let me try plus 3. Minus 1 didn't work. 9 plus 13 times 3 plus 3. Let me try minus 3. I mean, that has to work because that's the last one remaining. Yeah, so minus 3 works. So that means our factor is x plus 3. Now what we're going to do is we're going to divide this cubic function. We're going to do synthetic division on this cubic function. And again, synthetic division, we've done it many, many times. Not that difficult. The first number always comes here as it is. And then the next number, we multiply it with the divisor. 4 times negative 3 goes here. So that's negative 12. And then we add them. Negative 12, 1, negative 3, 0. So therefore our quotient is 4x squared plus 4x plus 1. Okay?
Mm-hmm.
Is that factorable? It's a quadratic now. Is that quadratic factorable?
It is.
How do you know? You tried the man thing, right? I'm
Mm-hmm.
guessing. Yeah, it's because it adds up, it multiplies to 4 and it adds up to 4, so it's factorable. So your two numbers are 2x and 2x. From the first two, you can pull out a 2x, you're left with 2x plus 1. From the next two terms, you can only pull out a 1, and you're left with 2x plus 1. So that entire thing is 2x plus 1 squared. And then our divisor was x plus 3. And then our initial divisor was x minus 3. And that's going to be the final answer here. So therefore, fully factored, you have your, because it was an x4 term, you have quadratic, you have linear, and that nicely adds up to be a quartic function. To graph this, again, not that difficult. You know your y-intercept is -9, and you have all your zeros here. So y-intercept is -9, and then your zeros are at +3, at -3, and at, where's our third zero from this x-intercept?
-1/2.
Yeah, -1/2. So we have a positive quartic function. A positive quartic function starts in quadrant 2, ends in quadrant 1, and the x-intercept of -1/2 has a degree of 2. Yeah? So
Mm-hmm.
that means it's gonna cross, or is it gonna bounce back?
Bounce back.
It's gonna bounce back. So let's see how that works. So at -1/2, it's gonna bounce back. So it's gonna come down, it's gonna go up, it's gonna bounce back, go through the x-intercept, y-intercept, and boom. Looks like a W, checks out, and that's the end of the question as well. So that's how you do that's how you graph a quartic function, even a quintic function, or any higher degree polynomial functions. You have to use the idea of factor theorem and then do multiple synthetic divisions depending on what degree function you're dealing with. Move away from this stuff. So inequalities. Let's look at inequalities. All right. So we dealt with a polynomial equation. Now let's see how we can decipher a polynomial inequality. So here's the question. When is this function greater than 0? Greater than 0 simply means positive. So we have to answer this question. There's two ways of doing this. They're both, one of them is easier than the other. I'm going to show you the harder one first. So the harder method is called the sign chart method. Both of them requires you to factor it, so it's not like one is considerably easier than the other, but let's start with factoring this because it doesn't matter which method you use, you have to factor it. How do we factor a cubic function? What are some possible a values here? So again, you look at the the y-intercept, sorry, the y-intercept is a 12, right?
Mm-hmm.
So your possible a values, the possible numbers that you check for is going to be the factors of 12. So it's going to be 1, 2, 3, 4, 6, and 12, the plus minus versions. So let's try with, I can already tell that 1's going to work because when you put in 1, the letters disappear. That's how I think of it. And right now, if you plug in 1, you're going to get a 0. So f of 1 is a 0. That means x minus 1 is a factor. Because you get 5 from this, plus 12 is 17, and then you do minus 17. That's why you get a 0 when you plug in 1. So now we've identified that x minus 1 is a factor. What's our next step? We need to fully factor this polynomial.
We do synthetic division.
Yeah, we do synthetic division. So 1 on the outside. On the inside, again, just double check that no x's are missing. We're good. So we add them. Synthetic division, the first number always comes down as it is. For the next one, we multiply. So this becomes a 2, 5. 5 times 1 is a 5, negative 12. Negative 12 times 1 is a negative 12, and we get a remainder of 0. That's what we expected. So now we have a quadratic, so we have 2x squared plus 5x minus 12. Is the quadratic factorable? Look at the quadratic. Is it factorable is the question. So we're looking for two numbers, right? What do they multiply to?
24.
Negative 24. What do they add up to?
5.
5. So it's going to be 8 and negative 3. So 2x squared plus 8x minus 3x minus 12. 2x, x plus 4 minus 3x plus 4. So that's 2x minus 3 and x plus 4. And then our original factor was x minus 1. Goes to this times x minus 1. And it was also, we just need the y-intercept and the sign. And this was our equation. So here's the first way of doing this. You have to factor it in both ways. The first way is we call a sign chart method. In a sign chart, what we do is we put in the x-intercepts and, as we'll see later for rational functions, the vertical asymptotes. We have to put them in terms of their ranges. Now here's what I mean. From this, our x-intercepts are what? -4, +1, and +3/2. Do you agree?
Yes.
So we have to divide the x-intercepts into 4 different ranges. It's always going to be n plus 1 sections. So if you have n x-intercepts, you're going to have n plus 1 sections on the sign chart. And here's how it works. The first one, you arrange your x-intercepts in ascending order. The first sign chart will always be x is less than -4, the first x-intercept. And then it'll be between -4 and +1. And then it'll be from 1 to 3/2. And then for the last section, it's going to be x is greater than 3/2. So from a number line, you have to account for all the different ranges of the x-intercept. So that's what goes on the top. And on the side here, on the sidelines, the factored things go here. So it's going to be 2x minus 3, x plus 4, x minus 1, the fully factored. And then at the very bottom, we're going to say f of x. That's when you multiply these three together, you get f of x per this. Now here's the hardest part, I think, when you start off with. Now what you have to do is you have to plug a number in each of these three equations depending on what the range is. So for our first range, x is less than -4, so I'm going to plug in -100. And the only thing you're interested in is the sign. So 2 times -100 minus 3, that's a negative. -100 plus a 4, that's a negative. -100 minus 1, that's a negative as well. So therefore, f of x multiplies. Again, f of x is the multiple of these three, so you just multiply the three signs. Negative times negative times negative is a negative. So therefore, f of x, our function is going to be below the x-axis. And then you keep going. Between -4 and 1, what's a nice number to plug in? 0. Okay? If you
Mm-hmm.
have a 0 in your range, you plug that in. 0 is here will give you -3. Here will give you +4. Here will give you -1. Therefore, the entire thing is going to be positive. Between 1 and 1.5, this is very tricky. 1 and 1.5, I'm going to plug in a 1.2. So you may even need a calculator for this. So 2 times 1.2 minus 3, I got a negative number for the first one. For the second one, I get a positive. 1.2 minus 1 is a positive, so the entire thing is going to be negative. And for the last section, x is going to be greater than 3 over 2. I'm going to plug in 1,000. So 2 times 1,000 minus a 3 is a positive. Positive, positive. The entire thing is positive. Now to answer the question, when is f of x greater than 0? That means when is it positive? Now you look at your signs. It's positive here and here. Therefore, the answer to the question is gonna be this interval and this interval. So for the final answer, it's gonna be negative 4x1 and x is greater than 3 over 2. In these two intervals, our f of x is greater than 0. And that's the end of the question. Using a sign chart method, which is definitely the harder method. Did this make sense?
Mm-hmm.
Now let me show you the easier way of doing this, and that is by using the graphing method. All we need for the graphing method is the x-intercepts, which we have there on the side. So now here's the graphing method. So in the graphing method, you just straight up graph your function. So negative 4, 1, and 1.5. 3 over 2 is 1.5. And the y-intercept is 12. So I'm going to go through this, 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 this. None of the roots are repeating. And we have a positive cubic. So it's going to start in quadrant 3 and end in quadrant 1. Now let's connect the dots. So we goes up, comes down. Now look at this. From the graph, when is the graph positive? It's positive right here. Do you agree?
Mm-hmm.
Between negative 4 and 1, it's positive. Where else is it positive?
When x is greater than 3 over 2.
Exactly. So when x is greater than 3 over 2. So I'm just going to show you how to write this in interval notation. Like that. So there you go. That's the answer. This answer and this answer are exactly the same. This one is in interval notation, and this one is in set notation. But as you can see, graphing is way easier than doing the sign chart. It's way quicker, right?
Mm-hmm.
But what happens is that sometimes it's not easy to graph. It's a polynomial here. Yeah, this one's very simple to graph. But later on, we're going to run into some complicated rational functions. And for those, it is next to impossible to graph it. So what we do is we just use the sign chart. Cool?
Mm-hmm.
So you need to know how to do both. Let's look at this next question. We have a cubic on the left, and it's an inequality. It's not an equation. Doesn't really change much though. The process for both inequalities and equations for polynomial, step number one is always factor. So what do you think the first step here is? Just keep in mind that you have a quadratic on the right side and you have a cubic on the left. What do you think we do in order to factor this or graph this? And that's something you always do with any polynomials. You need to have it equal 0, which means you have to move everything to one side of the equation. Okay?
Mm-hmm.
So here I'm going to move everything to the left side because that's where the higher degree term is. So step number one, move everything to one side. So x cubed, and then obviously collect the like terms. Negative 2 minus 2, the x squares become 4. Plus 5 minus 14 becomes minus 9. Plus 20 plus 16 becomes 36. All right. Now what? What's the next step? It's not equals to zero. Sorry, it's greater than zero. What will be the next step from here? You have to find a factor. In order to do synthetic division, you have to first find a factor, and that's only done via guess and check. There's no other way. So I'm gonna skip one. 36 has many factors. Well, I'm gonna skip ones because they don't work here. I'm gonna go with two. So let me try f of 2. And sometimes with these questions, you're gonna be trying for a while. So let's see, hopefully 2 works. I got a 10. So let me try -2 now. So -8 minus 4 times 4 plus 18 plus 36. So it's gonna be 30, so 2 didn't help. Let me try 3. 3 cubed minus 4 times 9 minus 9 times 3 plus 36. 3 worked, thank God. All right, so f of 3 gave me a 0, which means x minus 3 is a factor, right? And then what we do is we do synthetic division. 3 on the outside, and on the inside you have the coefficients of all these guys. Anything missing? Nothing's missing. Now let's do synthetic division. Not that difficult. 1 comes there. 3 times 1 will go here, so that's a 3. -1. That's -3. That's -12. That's -36 is 0. So our quotient is x squared minus x minus 12, which is x minus 4, x minus 3. And then we had another x minus 3 to begin with. So therefore, our cubic f of x is this guy. Now, what's the actual question? The question is, when is this guy greater than 0? Well, that wasn't the question. The question was this, but these two are equivalent. So instead of answering the first question, when is this complicated cubic function greater than this complicated quadratic function? We're just going to answer, when is this cubic function positive? This is the better question to answer, okay?
Mm-hmm.
I have seen people, dumb people do this, all right? I'm not saying it doesn't work, and I'm sorry I call them dumb, but this is the most ineffective thing you can do. I'm sure there's a way you can make this work. So this is what they do. They graph the cubic function, and then they graph the quadratic function, and then they're like, okay, when is the cubic function above the quadratic? In other words, when is the red line above the green line? And they're like, well, that's from here to here. So that's the answer. That does work, but the complicated thing about that is this may not be factorable. The questions are designed in such a way that only one variation of it can be factored. So if you use this approach and you factor your quadratic, but then your cubic can't be factored, then you're stuck. So this is definitely the better question to answer, this one. So what I'm going to do is this is a positive cubic function with a y-intercept at 36. So our y-intercept is 36. It's a positive function, starts there, ends there. And our x-intercepts are at 3. It's a repeated root, so it's going to bounce back. Because I should have written this as x minus 3 squared. So x minus 4 times x minus 3 squared. So we know that at positive 3, it's going to bounce back. 4 is here. So here's our curve. It goes through here, and then bounces back up. So what's the answer to our question? Our question was, when is the cubic function greater than or equal to 0? What's the answer? When is this greater than or equal to 0? Look at the graph. When is it above the x-axis? That's the question. It's not that difficult. It's right here. When x is greater than 4.
Mm-hmm.
And that's it. That's the entire question, and we're done. Not gonna bother with the calculator questions. Okay, so here it says, when is f of x greater than 0? Remember what greater than 0 means? It's positive. Well, let's look at A. When is it positive? Bit
Between 1 and 2.
1 and
And that
2, negative 1 and 2, right? Negative 1 and 2 here.
mhm,
Anywhere else?
when x is greater than 4.
Exactly. So it'll be negative 1, 2, and then 4 infinity. That would be the answer to A. Now you can see this is very simple. If this was inclusive, then these brackets would be round brackets. Sorry, not round. They would be square brackets if it was inclusive. If it's exclusive, then it's gonna be round brackets, open circle. For B, again, all of these are very simple, right? I guess you could just say, okay, here's the thing. For B, okay, for B, you cannot say x is strictly greater than negative 2. Because if you say this, you're saying that when x is exactly 2, we're positive. We're not. When x is exactly 2, we're 0, which is not positive. It says strictly greater than 0. So here's the answer to part B, okay? Just understand this. It's gonna be from negative 2 to 2 exclusive, and it's gonna be from 2 to infinity exclusive. All that means is that we're excluding the number 2, okay? It
Hmm.
means that. So at 2, it's not positive. To the left of 2, we're good. To the right of 2, we're good. That's what that means. Whereas if you say this as your answer, you're implying it's this, and that's wrong. So you have to break it down like this. It looks a little bit weird because you have a 2 here, 2 here. It's because 2 is not inclusive. C and D. Well, D, the answer is, okay, what's the answer to D? It has something to do with what I just said. What's the answer to D? And let me tell you, it's not XCR. When is D above the x-axis?
From negative infinity to 2.
Yeah, anywhere else?
And then from 2 to positive infinity.
Perfect, there you go. Do you know why you divided it into two intervals?
Because it's 0 at 2.
Exactly. If the question said f of x is strictly greater than 0, then, or not strictly, greater than equal to 0, then the answer to D will be XCR. Okay?
Hmm.
Because now you're allowed to include the 2, because you're allowed to be 0. It's again not that difficult, honestly. Okay, what about this one? F is the blue. Okay, F is the blue, and the question's asking us, when is the blue graph less than red? That means when is it underneath the red curve? Okay, when, for which x values? For which x values is the blue curve under, okay, under the red curve? So what's the answer to this? For which x values? It's a for which range of x values? It looks like from here to here, the blue is under the red, and then from here onwards, it's under the red. So your answer is these two intervals, from here to here, and then from here to infinity. So what's the answer? Looks like -1. So from -1 to +1, exclusive, because it says less than. And then from 2 to +infinity. So after this point, after here, the red will always be above the blue, right? If you extend them, you'll see that for any x value, the y value for the red curve will be more than the y value for the blue curve. So the answer to this question is this right here. And you're done.
Mm-hmm.
Again, not difficult. Okay, let's look at this one. A rock is tossed. So this is I don't know why this is here. This is a grade 10 question. Mm, but it's here, so let's solve it. Hope I think there might be a trick to this. So someone is tossing a rock into a river, into a ground. The cliff is 14 meters high. I can tell this because of the x-intercept when time is 0. And it follows a quadratic path. All right. Part A, how high is the rock off the ground when it is thrown? What's the answer to A? It's already on this page.
14.
14 done. B, how long is the rock in the air? How do we solve part B? How long is it in the air? So when you throw a rock, right, you have your height, you have your time. From 14 meters, you're throwing it, and it's taking this path. So how long is it in the air? Well, that's just going to be your x-intercept. That's the time it took to reach the ground from the top of the cliff. So what part B is asking you is, well, what's the x-intercept? Okay? How do you find the x-intercept of a quadratic?
You use math.
Okay, it might be a little bit tricky here. So it multiplies to +70 or -70
Negative.
and adds up to 12. What are they? I'm gonna use, so here, what I was gonna do was, I'm not gonna man because I can't think what multiplies to 70. 14,5 doesn't work. 35,2 obviously doesn't work. I can't really think of anything that works. 10,7 doesn't work. Can you think of anything?
No.
No. So let's go ahead and use the quadratic formula. So A is -5, B is 12, C is 14. And this is what the quadratic formula says. -b plus minus b squared minus 4ac over 2a. That's why this question is here, because we have to use the quadratic formula, I think. So 144 minus 4 times -5 times 14 divided by -10. So this is going to give us two x-intercepts. One of them will be positive. One of them will be negative. Which one do you think is the answer? The positive one or the negative one?
The positive one.
Yeah, obviously the positive one, because time cannot be negative, right?
Mm-hmm.
So yeah, this one was definitely a quadratic formula because the x-intercepts I got are very weird numbers. So for the negative one, I get -0.86. It's not a whole number. There's like goes on forever. And then for the other one, I got 3.26. So therefore, the answer is obviously 3.26 seconds. So now if we graph this quadratic, we know our y-intercept is -14, sorry, +14, and it's opening downwards. Not sure where the vertex is yet. Well, we know the x-intercept. It's 3.26, and this is -0.86. You remember how to find the vertex? How do you find the vertex of a quadratic? We already have the two x-intercept. Remember, HK is the vertex, H is always the midpoint of the two x-intercepts.
You add them and divide by
Yeah,
2.
you add them, you divide it by 2, I got 1.2. And then how do you find the y value of the vertex? You plug it into the equation. So once you have your value of 1.2, we're going to plug t as 1.2, and that gives me 21.2. So this should be a little bit thicker. 21.2. So there you go, that's the vertex. We didn't really need that for part B. The answer to part B is just 3.26. Part C, for what times is the height of the rock greater than 17 meters? So what this next question is asking you is that's why we have a graph, right? Even though the question didn't ask us to draw a graph, it's always helpful to have one because look at this for part C. Now what part C is asking you is there's this line 17 meters. What are the x values? So this will give you an x value down here. This will give you an x value down here. So between these two x values, the rock is greater than 17 meters, right?
Mm-hmm.
So we need to find those two x values. How do you find them? How do you find the point of intersection between two curves? We need to find this point and this point. This line is y equals 17. This line is, well, this. How do you find the POI? Do you remember?
You set them equal to each other.
Exactly, you set them equal to each other. So what we're going to do is negative 5t squared plus 12t plus 14 greater than 17. Okay? Why greater than? Because it says greater. So now we have a quadratic inequality. Does that change anything? Not a whole lot. The steps are the same. Step number one, for any polynomial, equation inequality doesn't matter. As long as you're dealing with a polynomial, everything has to be on the same side of the equation. So I'm going to move the 17 to the other side to get negative 3. Like that. Now let's man this, see if we can graph this quadratic. So multiplies to positive 15, adds to 12. The only thing that multiplies to 15 is 5 and 3. So it looks like this is going to be another quadratic formula question because man doesn't work. So I'm going to save some time. Okay, just pretend like I use a quadratic formula. So for this one, I got two x-intercepts. I got 0.28 and 2.12. So let's graph this. I'm just graphing this quadratic. So negative 3 is here. Our x-intercepts is 0.28 and 2.12. So this is what our curve looks like. And what are we trying to find? We're trying to find when is this curve above or below the x-axis? What are we trying to find? Above or below?
Above.
Above. So from this sketch, we can see that it's above right here, between these two x values, right? Between these two x
Mm-hmm.
values. And that's the answer to part C. Okay? For what times is the height of the rock greater than 17 meters? Well, that is going to be from 0.28 seconds to 2.12 seconds. And it also makes sense with respect to the points we already have here. That's the answer to part C, between these two. Part D, how long is the rock above a height of 17 meters? So part D is actually very simple if you know what it's asking for. It's a 5-second answer. What's part D asking us? I'll give you a hint. It's a subtraction. So we're trying to find how long was it in the air for above 17 meters. Well, that's the distance. That's the time, sorry. That's the time from here to here, okay? Right, this period of time. So that is simply the difference between these two x-intercepts, these two x-intercepts. So the answer to part D, 2.12 minus 0.28. During this time, our ball or whatever rock took this path, and it was in the air for 2.12 minus 0.28 for 1.84 seconds. And
Mm-hmm.
that's the answer to part D, and we're done with this question. So again, this was initially started off as a grade 10 question, but because we had to use the quadratic formula and also because we had an inequality, it kind of morphed into a grade 12 problem. Okay? All right, let's
Mm-hmm.
just call it there for today.
Okay, thank you.
See ya.